All right, today we are diving into some seriously cool research from NVIDIA. They've essentially built an AI that's a total pocket rocket. It's got the power of a giant model, but in a tiny package. And trust me, this could change everything. Let's get into it.
So, this is really the million-dollar question in AI right now. We keep hearing about these absolutely enormous models that are changing the world, right? But what if you could get that exact same brain power, but in a package that's way, way smaller?
The best way to think about today's top AI models is to picture them as supercars. They are incredibly powerful, they can do just unbelievable things, but man, they are absolute gas guzzlers. They need a staggering amount of data, energy, and computing power. And that really limits who can build them, who can even afford to use them, and what they're actually practical for.
And this whole supercar problem, it's become a major roadblock for the entire AI industry. It feels like this unbreakable rule. The smarter the model gets, the bigger, the hungrier, and the more ridiculously expensive it becomes. It all boils down to this fundamental trade-off. On one side, you get this amazing, mind-bending power, advanced reasoning, results that were science fiction just a few years ago. But the price you pay for that is just astronomical computational cost, the need for super specialized hardware, and the fact that it's out of reach for pretty much everyone else.
But what if you could just break that trade-off? What if you could have your cake and eat it too? Well, that's exactly what NVIDIA set out to do.
And this is the paper that got us so excited. It's called Nematron Nano 2, an accurate and efficient hybrid Mamba transformer reasoning model. Yeah, I know, it's a total mouthful. But hidden in that title is the secret to how they created a tiny model with the brains of a giant.
Before we get into the nitty-gritty of how they pulled this off, just look at the result. This new model can deliver up to 6.3 times higher throughput. That doesn't just mean it's a little bit faster. It means for certain jobs, it's on a whole other level of efficiency. So what's the secret sauce? Well, the clue is in the name. It's a hybrid Mamba transformer. Okay, so transformers are the architecture behind giants like GPT. They're incredibly powerful, but kind of slow. Mamba, on the other hand, is a newer architecture that is insanely fast. NVIDIA had the brilliant idea to just combine the best of both. So let's peel back the curtain. How did they actually build this little powerhouse? Let's break down NVIDIA's recipe. NVIDIA's whole approach really comes down to three key ingredients. First, that smart hybrid design we just talked about. Second, a world-class data diet to make it smart in the first place. And third, a really, really clever process for shrinking the model down without making it dumber. This quote from the paper really gets to the heart of it. Think about a normal transformer. It uses these things called self-attention layers to understand context. It's kind of like having to reread the entire book chapter for every single new word. It works, but it's slow. NVIDIA went in like a surgeon and replaced most of those with these super fast Mamba 2 layers. And that's where the speed boost comes from. Okay, next, the data diet. An AI is only as smart as the data it learns from, right? Nematron wasn't just fed a bunch of random stuff from the internet. No, it was trained on this really rich, high-quality mix of multilingual data, computer code, and mathematics. That diverse diet is what gives it such powerful reasoning skills.
But here's where the real magic comes in. They started with a much bigger model, one with 12 billion parameters, and then they had to shrink it. You can't just start chopping off pieces randomly. That would be like giving the AI a lobotomy. You have to be more like a sculpture, carefully chipping away to reveal the perfect shape hidden inside.
And this is what that sculpting actually looks like under the hood. Before they even think about compressing it, they put the model through this multi-stage alignment process. This involves things like supervised fine-tuning, which is basically like giving it an answer key to study from, and reinforcement learning, which is more like having a human coach give it constant feedback to really sharpen its abilities.
Then comes the final step, compression. And they use two really smart techniques here. First is pruning. Think of it like a neurosurgeon carefully removing brain connections that aren't absolutely critical. Then there's distillation, where the big, smart 12 billion parameter model acts as a teacher to the smaller 9 billion parameter model, basically teaching it all its tricks so it can reason in the same sophisticated way. So they've got this smart new architecture, they've fed it amazing data, and they've sculpted it down to this compact size. But the big question remains, did it actually work? I mean, this is the real test, isn't it? Can this compact 9 billion parameter model actually step into the ring and hold its own against the heavyweights? Well, the results just speak for themselves. Look at this. When they tested it against a comparable state-of-the-art model, Nematron Nano 2, that's the green bars, performs just as well, or in some cases even better, on really tough tasks like math and coding. The takeaway here is simple. It's just as smart.
But being just as smart is only half the story. And this is where it gets absolutely incredible. While being every bit as intelligent, Nematron is anywhere from 3 to over 6 times faster. That is the massive payoff from that hybrid design and clever compression. It's not just smart, it's wicked fast. So what does this all mean for you and me? It means you can now get state-of-the-art AI reasoning on a single, pretty accessible GPU needing only about 22 gigs of memory. This is no longer some exotic tech that can only live in a massive data center. The huge takeaway is that incredibly powerful AI is finally becoming accessible to everyone. And that just leaves us with one final, very powerful question to think about. This research proves that elite, top-tier AI doesn't need a giant footprint anymore. So what new tools, what new creative ideas, and what amazing applications are going to be unlocked now that this kind of power can run anywhere for anyone?